So this is part 2 of the example of the spring 2021 exam. And so I already talked about the first year, how we get this. And now we're looking at the second year. And in the first video, you recall I already showed how we get these values right here. And you'll notice that these two values, so this one having a 5% decrease and this one having a 10% increase, they're the exact same. And that should make sense with a binomial tree like this. And so we need to buy a put option for each of these scenarios right there. So I have the up scenario put option and the down scenario put option. Because these are not at the money put options, we can't use this sell. And so we need to use Black-Scholes, which is our is now the risk neutral part, and we just did the real world part right there. So our K is at $10,000 because we need to just return the premium. So if there was any, if this accumulated at 3%, our strike price would be different. But this is just a flat amount. So $10,000. And for the up scenario, we have our price of our stock is after the management fee, which is right here. And then that's for the down scenario too. And then I calculated D1. And so this formula, you just look up the standard Black-Scholes formula. It should be pretty simple and straightforward. Just note that the only difference I made is for my volatility, I used the 31.62%, which is just the square root of that amount because I messed up on this question. It was a defective question, like the SOA always does defective questions, but alas, here we are. And so here's our D1 and our D2. And then for calculating it this normalized, I didn't use this table. I actually, you could approximate it using this table, but I just used the norm.s.dist, and I needed to do the negative amount of the D1 because of this put equation right here. And then that's where I got these. And then I also calculated D2. Note again, I used the 31.62% for sigma. And that is where you get the put costs right here at the very end. This formula is just based off of this equation up here. For my payoff for year 2, I just did the expected value of, so there's the payoff right there. But the cost, this is the average of these two right there. And so there you go. There's the cost. The payoff is, I just did an average, like a weighted average of the difference of the 10,000. Notice that this has a 50% chance of this blue cell right there, and I'm just including this scenario right there as a 50% because each of these have a 25% chance of happening. And then a 25% of 10,000 minus this red cell of the down scenario right there. However, your GMAB, or I put here GMAB, the expected payout should equal this amount because we need to, at the end of year 2, they're going to surrender. And so we need to pay back the $10,000 at least. And so this payoff right here, all the benefits we get, we also have to pay that back in expenses. And so I have here for my final answer a profit or loss of the revenues minus expenses. You're going to notice that my solution is a little bit off of the SOA solution, and that has to do with the rounding of the D1s and the D2s.